Hello and welcome to this session in Java Developer Live. I'm Poonam Parhar. I work in the Java platform group at Oracle. And in this session today, we are talking about monitoring and troubleshooting tools that are shipped with JDK. So before we talk about all the tools, a few words about troubleshooting. What is troubleshooting? So it's a systematic approach to solve problems, and it involves three simple steps. The first one being identify the problem or error you are encountering with your Java applications, and collect the required diagnostic data to understand the problem better, and then analyze that collected diagnostic data to get to the root of the issue and to resolve it. And with all these steps, good troubleshooting tools are our friends. So monitoring and troubleshooting tools in JDK, and there are bunch of tools available in JDK bin folder, and these tools allow us to monitor Java applications, profile them, extract useful diagnostic information from our Java applications, analyze that diagnostic data, and these tools even help perform after the fact analysis. And these tools can work locally as well as remotely. So the agenda of this session is we'll be talking about monitoring and troubleshooting tools in our JDK bin folder. And I'll also go over some of the new tools that have been added in recent Java releases. And we'll also go over a few others which have been removed from the JDK. Monitoring tools. So among monitoring tools, we have jconsole, which is a GUI-based tool to monitor and manage Java applications. JPS, Java Process Status Tool, which can list the Java processes running on your machine. JStat, JVM Statistics tool, as the name suggests, it helps collect JVM statistics from Java processes. jstatd, JVM Statistics daemon, and this tool enables remote monitoring tools to attach to remotely running applications. JMC, Java Mission Control, which has three components, JVM browser, jconsole, and it also helps in recording and analyzing JFR files. JMC has been open sourced and it's no longer shipped with Oracle JDK, but JMC bundles are released separately by Oracle. All right, so the first tool on our list, which is jconsole, as I said, it's a GUI-based monitoring tool for Java applications. It's a JMX client, which means that underneath it uses JMX technology to connect to Java applications. And it helps in monitoring and managing not just Java applications, but the JVM as well. And it can monitor local as well as remotely running applications. And this tool can be launched using jconsole executable in JDK, available in JDK bin folder. It's not recommended to run jconsole locally on the same machine where the target process or application is running, because this tool itself consumes significant system resources, and that might impact the performance of the application being monitored. And for remote monitoring, we can use this property jmxremote.port to specify the port number at which jconsole should be connecting to the remotely running application. So a little bit on how a JMX client application actually monitors and manages the resources of a Java application. So as I said, jconsole is a JMX client application, and a JMX client application connects to the JMX agent running within the target JVM. And at the core of this JMX agent, there is mbean server. And there are mbeans, which are actually Java objects available or implemented at the Java application level. And these Java objects, make available attributes and operations for the resources they manage. And these mbeans are registered with the mbean server. So through the JMX agent and the mbean server, JMX client gets access to the resources and their attributes and operations, which are exposed through mbeans. Snapshot of jconsole. So this is there are various tabs which are available, various views which are available in jconsole. And the first one being the overview, which provides a higher level view of the resources and their usage of our Java application. For example, here we can see that the overview tab shows heap memory usage, number of threads running in the application, loaded and unloaded classes in the application, and the CPU usage of a Java application. And then there's a memory tab where you can get detailed level information of heap memory usage, or you can switch between heap and non-heap memory pools. For example, you can get details of memory usage of old generation or Eden space from Java heap section, or you can also get details of memory usage of meta space, class space, etc. Threads tab gives us detailed information of number of threads running in the application, the names of all the threads running in the application, and when we click on any specific thread, we get additional information about the thread and its stack trace. The classes view again gives classes related information, number of loaded classes, how many classes have been unloaded so far in the application. And VM summary just provides summarizes all the information available in other tabs in a textual format. So jconsole also has a mbeans browser, and this mbean browser allows us to access all the mbeans registered with the platform server, mbean platform server. And through this view or through this tab, we can access all the attributes and operations exposed through those mbeans. For example, in this case, we can see that there is a diagnostic command mbean, and it has all these operations shown on the left-hand side. And we can click on any operation. It shows more detailed information about that operation. And jconsole also allows us to execute that operation. For example, if we click on GC run finalization, it would run finalization in the target or in the attached Java application. JPS, Java Process Status Tool. So as we all know, it shows all the Java applications or JVMs running on the system, and it obtains the process related information from the process specific files, which are available under /temp hsperf_data_user folder. And underneath, it uses JVM stat technology, which can be enabled or disabled using use perf data flag. And by default, it is enabled, but this flag allows us to disable it if we want to. And the list of JVMs, which is shown by this tool, can be limited based on the OS level permissions that are available to the user running this tool. And it can list the JVMs on local as well as remote machines. And for remote monitoring, there's another tool, jstatd, and it should be running on the remote system. And it accepts optional argument in this format, protocol, host name, port, for us to be able to use JPS to monitor, remotely running applications. And for local machines, the VM identifier that is shown by this tool is usually the process ID, OOS process ID of the application. A few examples how JPS can be used. Dash help shows us how JPS tool can be used, what all different options it accepts. For example, dash M shows the process ID of the process, the class name or the package name that was used to launch this process, and if there were any arguments that were passed while launching that specific process. So similarly, we have dash L, dash V, and dash Q that show different levels of detailed information about processes running on the system. JStat, JVM Statistics, and it is a very helpful tool to obtain JVM statistics. This tool is really useful in gathering performance statistics about the HotSpot JVM. And this tool also reads process information, statistics information from the PID files or the process files available under /temp hsperf data_user folder. And it accepts various options to print statistics about different components of the JVM. For example, class or compiler would print class-specific or JIT compiler-specific statistics information about the JVM. And for remote monitoring, again, jstatd tool should be running on the remote system, and it accepts this optional argument to for us to specify the protocol it should use to connect to remote system, or the host name of the remote system, and the port number at which jstat should connect to the remotely running application. jstatd, so it basically is a daemon that enables other tools to monitor applications, Java applications remotely. So it's an RMI server application that monitors the creation and termination of HotSpot JVM applications. And so this tool basically provides an interface using which the other JDK tools can attach to remotely running Java applications. An important thing to note here, there's no encryption or authentication with jstatd, so it should be used cautiously on production environment. All right, so that brings us to troubleshooting tools. Among troubleshooting tools, we have jcommand or Java command tool. And this tool allows us to send diagnostic commands to a JVM or JVMs running on local machines. JDB, Java Platform Debugger, that allows us to debug Java code or Java class files. jinfo helps us to obtain or update flags or configuration information. jmap, Java memory map, and it is I think it's the most popular tool in the toolkit, and it can create heap dumps, heap histograms for a Java process. jstack, it can print Java stack traces for a Java process. And jshdb, Java Hotspot Debugger, and it's a post-mortem tool and can attach to a stuck or hung process, and it can explore or examine crash dump files as well. JFR command line tool, and it's a tool to analyze JFR recording files. So jcommand has been the focus of development and enhancement in recent releases, and a lot of new diagnostic commands have been added to this tool. jshdb, it's a new tool which was added in Java 9. JFR command line tool, again, a new tool which has been added in Java 12. Let's start with the jcommand or Java command tool. So it's it's a diagnostic utility, and it allows us to send diagnostic commands to a running JVM or multiple JVMs running on the local machine. So as it uses attach API under the hood, so it cannot work with or send diagnostic commands to remotely running application. It can work only on the same local machine as the target JVM, and it uses attach API to send these commands and execute these diagnostic commands or helper routines in the JVM. So some helpful commands that can be used with jcommand. The first one being gc.heap_info. This is very helpful to monitor the heap usage of a Java process or application, and it prints out the heap usage and the size of various memory pools of Java heap. gc.heap_dump. This option can be used to create heap dumps from running live Java applications. And gc.class histogram can print object histograms. So all these three commands, diagnostic commands, are really helpful in diagnosing and troubleshooting memory-related issues with Java applications. The next one, thread.print, it can print Java stack traces. vm.native_memory is very helpful in tracking native memory allocations done internally by the JVM. vm.metaspace is helpful in printing out metaspace usage information. And vm.flags prints out the JVM flags and their current value, which is being used by the running JVM. All right, Java flight recording related diagnostic commands that can be used with jcommand. JFR start can start a JFR recording in a running application. JFR check lists out the recordings that are already running in the target JVM. JFR stop can stop an already running JFR recording, and JFR dump can dump the recording information onto disk in a JFR file. So as we can see in this example, jcommand is sending jfr.dump command to process ID 5127, and we are telling it to dump the recording to a file recording.jfr on disk. And we are passing an additional argument, path to gc roots is equal to true, which means that gc roots information for live objects should also be dumped in the recording file when the recording file is saved on the disk. Okay, so jcommand carries its own documentation. So jcommand, the help command with jcommand can show us all the diagnostic commands that are available in a target JVM or a process. For example, in this case, we are using jcommand test help. So this lists all the commands that can be used with process test or Java program test. These commands can be passed, jcommand can use these commands with test process. Some examples and the output shown by various jcommand commands here. For example, in this case, gc.heap_usage shows the memory usage details. It shows the size of the Java heap and its current usage. Jcommand test gc_finalizer info command shows finalization related information, or whether there are any objects or instances waiting for finalization. gc.class histogram can print object histogram, which is really helpful in understanding the heap usage, which are the objects that are occupying the most of the space in our Java heap. and can help in tracking memory leaks or memory growth related issues. Thread.print prints out Java stack traces of all the threads in the target process. Okay, so how jcommand communicates with the target JVM to pass on the commands and execute those commands, and how it gets the output. So as I said, jcommand uses attach API to connect to a target JVM, and using this attach API, it can it sends over the commands that are available with that in that target JVM, and corresponding to the command which is sent to the target JVM, a diagnostic routine or a helper routine is executed inside the JVM, and the results are then sent back to the jcommand tool and presented to the user. So since attach API can be used to communicate with only local processes, jcommand can work only with the Java processes running on the local machine. All right, so next tool on the list, JDB, which is a Java debugger, and it's a command line tool, can be used to debug Java class files, and it uses Java debug interface, JDI, and JDI is a component of JPDA, Java Platform Debugger Architecture, and JDB can perform, inspect Java processes or debug Java applications locally as well as remotely. jinfo, Java configuration information or Java flags information tool. So this tool can obtain flags related information of a running Java process, and it can also update the manageable flags at runtime. So all the capabilities of this tool, it can print the value of a VM flag, it can enable or disable a specified VM flag, it can set the value of a manageable VM flag, and it can also print the values of system properties as well. Next tool on the list, jmap, Java memory map. This tool is really helpful in obtaining heap objects information and creating heap dumps. There are various options that are available with this tool. For example, CL stats can show us class loader statistics, all the class loaders available in a running application, the classes loaded by that particular class loader. Finalization information can be printed using the -finalizer info. It's helpful in creating class histograms using -histo option, and jmap can create heap dumps. So a couple of features, heap info and printing out shared memory mappings have been removed, and they were removed in Java 9. We'll take a look at why certain features were removed from various tools in specific Java versions. JStack, Java stack can print thread stack traces. It also can execute, it can perform deadlock detection. And JStack with the -L option can be used to see concurrent lock information. Again, there were two options, -F and -M, that have been removed in JDK 9. With -F, we could connect JStack to hung or stuck processes, and -M could be used to print native frames and stack traces. So there are alternatives how that information can be obtained. We'll take a look at that in later slides. So up until JDK 8, these three tools, jinfo, jmap, jstack, could connect to local live processes, code dump files, and could also monitor or could be used with remotely running applications. And the support of code dump file and monitoring or working with remotely running applications was provided by Serviceability Agent, which is a HotSpot Debugger tool. And in JDK 9, this support, the Serviceability Agent support, was removed. And now these three tools can no longer work with code dump files and a remote debug server or remotely running applications. And these tools can only monitor and manage local live processes. Now, a quick comparison between jcommand and some of the older individual tools. For example, if jcommand is used without any argument, it lists all the Java processes running on a target system, which is what JPS does. So jcommand provides same kind of functionality as the JPS tool. Now, when jcommand is used with commands vm.system_properties or vm.flags or vm.setFlag, it provides the same kind of information as jinfo provides, and jinfo allows us to perform certain operations on a running application. When comparing with jmap could generate heap dumps, class histograms, or get object histograms and get class statistics and finalization information, and all that can be done with the jcommand tool as well, using various commands. Now, jstack could print thread stack traces. Jcommand can also print thread stack traces using thread.print command. Jcommand can print performance counters as the jstat tool can. So you have jcommand tool, one-stop, all-in-one tool, and it provides all of the features which are available with other individual tools. So I would encourage you to start using this tool if you haven't done already. So you don't have to depend on independent individual tools, and you just have one tool to perform all the features. As we saw in an earlier slide, that jinfo, jmap, jstack cannot now work with code dump files or cannot monitor remotely running applications since Java 9. And in Java 9, a new tool was added, which is called jshdb, Java Hotspot Debugger. And it uses a serviceability agent under the hood to connect to local live Java processes, code dump files, and remote debug server. So let's see what this tool can do. JHSDB, Java Hotspot Debugger. It can be used to launch a post-mortem debugger or serviceability agent to analyze code files. It can also be used with the live Java processes. And we can use JHSDB tool to launch various other tools. For example, CLHSDB command with JHSDB can launch command line hotspot debugger tool. We can launch UI-based hotspot debugger or serviceability agent with HSDB command. And likewise, you can use jstack, jmap, jinfo, along with through JHSDB to attach to remotely running applications or examine code files, and even use that with live Java processes as well. Okay, so let's go over some examples how JHSDB tool can be used. So here in this case, we see that JHSDB, we are launching the command line hotspot debugger with the JHSDB tool. And once it is launched, we can use help command inside the prompt of JSDB tool to see all the commands that are that can be used with a process or a code file. In this example here, we are using JHSDB against a code file. Okay, so from within the prompt of HSDB, we can print stack trace of all the threads running in the application. We can also examine or inspect a particular address which we might be interested in. For example, in this case, I want to see the internal details or internal fields of method 1 at the highlighted address. Here I can see, use the inspect command to see the internal fields of a method object. It also allows us to search a particular address within Java heap or search that address in the stack of various threads running in the application. So JHSDB tool can be used to launch the GUI-based HotSpot Debugger tool as well. Here we can see it shows us Java threads running in the application, and we can inspect objects using this tool. It also allows us to see object histograms, and it allows us to search for a particular address in the Java heap. And I have found this feature really helpful when you're trying to see, the GC roots or the ref chain of references through which a particular Java object is reachable in the Java heap. HSDB also has this feature through which you can look at the stack memory of threads, and it shows the VM structures or the Java objects which are present on the stack memory of any thread. So just jstack tool can also be launched using JHSDB, and through that tool we can connect to code files or remotely running applications. And in this case, I'm using jstack with a code file and printing mixed stack traces. As I mentioned before, there was a the -m option, which was removed from the jstack tool in JDK 9. And using this mixed flag, we can get those native frames in stack traces. Jmap can also be launched using the JHSDB tool, and it allows us to print Java heap summary or create histograms or create heap dumps from code files. So here I'm viewing histograms from a code file using jmap, launched using JHSDB. So jinfo tool is also available with the JHSDB tool, and from code file you can see all the VM flags and their current values, what your Java process had, and at the time when the code file from it was generated. All right, so the next tool that we are going to talk about is JFR command line tool. This tool can examine JFR recordings, and it is very helpful when we cannot use GUI-based tools that can explore and examine JFR recordings. And this tool is available since Java 12, and it was also backported, and it's available in JDK 11 as well from update 6. So this is how JFR tool can be used. It has a command called print, or rather option called print, and this can print events from JFR recordings on the command line in XML format or JSON format. You can also specify the categories of events that you're interested in, or you can specify specific events that you want to look at. It is also possible to specify the depth of stack or the number of frames that you want to see in stack traces. Some examples in the first one, you just say, I am just saying that I want to see all the events available in recording.jfr file. And in the second case, I'm specifying that I am interested in looking at CPU load and garbage collection events. And so the information about those events gets printed, and I can print that information in JSON format. There are two other options that can be used with JFR summary, which summarizes the recording file, summarize information from the recording file, and metadata, which can print metadata information about events from the specified recording file. So talking about some of the tools which are not shipped with JDK now, from JDK 9, Java VisualVM, JHAT, jstatd were removed, and they are no longer shipped with the Java releases. And in JDK 11, JMC tool was removed, but it's separately made available by Oracle in other ways. So Java VisualVM, as I said, it's not included in JDK since JDK 9. It has been open source, and the open source project is available here. So for profiling and live monitoring, which were the key features made available by Java VisualVM. And so those features are available in Java Mission Control and jconsole. So these two can be used as alternatives to Java VisualVM if you don't have access to this remove tool. And there are several open source tools available which can be used for heap dump analysis. JHAT, this was removed in Java 9, and it's basically a web application that can be launched with the JHAT tool available in JDK bin folder, and it enables heap dump analysis. It allows us to browse objects in heap dump using a web browser. And JHAT supported a wide range of pre-designed queries and object query language to explore objects in heap dumps. But having said that, there are several other heap dump analysis tools, for example, Eclipse Mat, that can be used for heap dump analysis. Moving on to jsadbd, which was removed in Java 9. It attaches to a Java process or code file and acts as a debug server for enabling tools to monitor applications remotely. So up until JDK 8, this tool allowed jstack, jmap, jinfo to attach to remotely running applications. And this debug server tool can now be launched with jshdb. JMC has been open sourced, and the open source project is available at this link. There is a very helpful blog written by Marcus Hurt where he talks about how to get the open source, source code, how to build it. And JMC is not shipped with JDK, and it's been removed from bin folder since JDK 11. So Oracle prepared JMC bundles and releases are available at this link. So JMC offers a tool chain, and as part of that tool chain, it has JVM browser, jconsole, and Java flight recorder, engine and analysis tool. So a quick look at what JMC look like and can do. So here we can see that, JMC, this shows the JMX console of JMC. It shows an overview of CPU and memory usage of the application from which the JFR recording was collected. So this is not with the JFR recording. This is monitoring of the live Java process. So you can monitor the CPU usage and memory usage of the live Java process using the JMX console. It has other tabs where you can obtain detailed level information about memory and threads, and you also have an MBean browser where you can go through, browse all the MBeans registered with the platform server of the application. And as I said, it has Java flight recording analysis tool. It can perform automated analysis. It can, point out if there are any potential functional or performance problems in the application, and it also makes recommendation and suggestions how those problems can be avoided. Okay, so that brings us to the end of the presentation, and to summarize what all we talked about, the jcommand tool, it has received many enhancements, new features, new diagnostic commands have been added to this tool. So I would encourage you to use this tool if you haven't if you're not already using it. And there are a few new tools that have been added to the toolkit: JFR command line tool and jshdb tool for postmortem analysis. Some of the tools have been removed from the JDK: Java VisualVM, jhat, jsadbug, and JMC. Thank you.